How can we reconcile these clocks? We can reconcile them if 1.5 billion years worth of nuclear decay, as measured at the present decay rates, in fact occurred in only 6,000 years. Helium is a byproduct of uranium decay. When uranium decays to lead, it goes through 8 steps, 8 alpha particle decay steps. The alpha particle is 2 neutrons and 2 protons. It goes out into the zircon where it picks up electrons. And so it gets 2 electrons to balance the 2 protons, and that's a helium atom. So helium is actually a byproduct. Every uranium atom decays to produce 8 helium atoms. Deep drilling, they drilled a drill hole near Los Alamos, New Mexico. It's called Benton Hill. And they drilled this deep drill hole into this granite to where they knew the rock was warmer to explore for using geothermal energy. And in that granite were different zircon grains, and they recovered zircon grains from different depths in that granite, down in that drill hole. And of course, they knew the temperature. They could measure the temperature in the drill hole from where they collected the samples, from where they got the zircon grains. Okay? And so they also knew the age of these zircon grains, and the uranium lead age, it's in the literature, was published. The uranium lead age for these zircon grains was 1.5 billion years, 1,500 million years. So here's the different depths down on the left there. The helium was retained in these zircon grains. It was measured. You can see the temperatures. At 750 meters down, the rock was 95 degrees warm. You go down to 960 meters, it was 105 degrees Celsius. That's above the boiling point of water. So it was quite warm. No wonder they were looking for geothermal energy potential. Notice how much helium was retained. At 750 meters, 80% of the helium that would have been produced by 1.5 billion years of decay was retained. But as you went down the drill hole, the hotter the rock, the less helium was retained. Why? Because helium leaks out of the zircon grains. It's lightweight. The hotter the crystals, the faster the helium leaks out. Helium is a lightweight atom. It's only atomic weight 2. It's fast moving. The warmer the atom, the more energy it has to wriggle its way out, and it can slip easily between the zirconium, the zirconium crystal in the zirconium crystal lattice, which is made up of zirconium, silicon, and oxygen atoms. So, taking those results that were published in the literature, the helium leakage rate determined by how much percentage that was retained, 1.5 billion years worth, 80% retained at 750 million years. What's the leakage rate? Go down deeper, hotter, a higher leakage rate. So we plotted the leakage rate versus the temperature on this graph, okay? And before the leakage rates from these zircon grains were actually measured in the laboratory, we made predictions. The leakage rate equals the helium lost, 80%, over the time. Okay? So for 1.5 billion years of decay, how long did it take for 20% to leak out? That was the leakage rate. But if instead it was only 6,000 years, the biblical creation model, thereabouts, 6,000 years, then the leakage rate would have been faster, because 20% would have been lost in 6,000 years rather than in 1.5 billion years. So you get where I'm going here? So when we plotted that, the leakage rate on the left, diffusion rate, versus the temperature, for the two different models, the 6 samples, 2, 4, 6 samples, gave 2 curves that were a factor of 100,000 different, 5 orders of magnitude different. And we published these predictions before we sent our own samples away for further testing to actually measure the diffusion rate. Okay, so we predicted if the diffusion rate was very fast, it would fit the 6,000 years creation model. If it was very slow, it would fit the 1.5 billion year model. Okay? The leakage rates were measured in a world-class laboratory by a secular geologist who didn't realise where the samples had come from and who had sent the samples. And look at the data. The black dots, the top right there, at the lower temperatures, they overlapped with the 6,000 year model. They didn't fit the 1.5 billion year prediction. Wow. Talk about an experimental confirmation. Furthermore, if we look at these leakage rates and the amount of retention of helium, we can calculate the various diffusion rates for each of those samples. And the average is almost 6,000 years, a little less. Wow. How can we reconcile these two clocks? Remember, helium diffusion is a physical process that follows a known physical law, the diffusion law. Okay? So here we have two clocks. The helium diffusion gives an age of only 6,000 years, and that helium is derived from 1.5 supposed billion years of nuclear decay to form lead. And they disagree by millions. How can we reconcile these clocks? We can reconcile them if 1.5 billion years worth of nuclear decay, as measured at present decay rates, in fact occurred in only 6,000 years. In other words, that uranium decay was accelerated grossly at some past catastrophic event. So that's further confirmation of accelerated nuclear decay in the past.
It really is a great time to be a biblical creationist. The helium and zircon crystals, the radio halos, which I've learned so much about the significance of radio halos from you, the C14 endowments, the discordant dates. One thing comes to mind is I've seen, and I'm curious as to your thoughts, and hopefully I can reiterate this well, but I've seen many critics, especially on YouTube, they'll argue against the data that powerfully confirms a young Earth, Dr. Snelling, with the abundance of helium being a slippery atom. The abundance of helium and known diffusion rates gives us an age of roughly 6,000 to 10,000 years, plus or minus. And they'll say, well, the rate team basically assumed relatively constant temperatures throughout Earth's history. And so if it was colder or hotter, or they made other assumptions, then we wouldn't get the evidence for a young Earth. Have you heard that criticism? And what would be a good way to respond?
Yes. Well, it's been responded to. It's been responded to by John Baumgartner and Russ Humphreys. Articles available on the website. Again, such critics haven't done their homework. Some of these critics will say, "Oh, but there's evidence of recent volcanism over there near Los Alamos in the area of the drill hole where the zircon crystals were taken from the helium diffusion experiments." But if you do the calculations, those zircon crystals, to get the results, would have to have been kept at almost 0 degrees for millions of years, which obviously is geologically totally untenable. Right. Nobody's said that. And that's been reported. This has been written up, and these critics refuse to read those articles and refuse to acknowledge that their arguments have been debunked.
You know, to me, and then Sam, I know you have a question on helium as well. To me, seeing that these are their challenges in rescue devices, Dr. Snelling, and how easily debunked they are, the fact that they have been debunked, but they repeat them, to me as a creationist, especially a creationist apologist, that's really encouraging. Yeah. Because that tells me they've got nothing better.
Yeah, it is encouraging, but also means, of course, that when we do our work, we need to do our homework as well to make sure that we've read their literature to get it right in what we're saying. And we endeavour to do that. And so, that's why, for example, early in my presentation, I showed you examples from their literature that document the very things that I'm saying. So people can't say, it's not Dr. Snelling dreaming up that you get young potassium argon ages from young lava flow. You get old ages from young lava flows. No, it's in their own literature. You don't get inheritance and you don't get contamination, just from your claims. It's actually documented in the literature, their literature. So we do our homework.
Wow, I love it. Sam, over to you, brother.
Yeah, so I have a critic who raises a similar criticism, but it's different. So this critic suggests that the helium leakage rates that you guys used, that you came up with in your laboratory, were based off of a constant temperature. However, you compared them to the thermal vents, which have the temperature fluctuations, as you pointed out in your presentation.
How do they know it was a constant temperature? The laboratory measures the diffusion rate by raising and lowering the temperature in the laboratory on those zircon crystals. The critic who's making that claim doesn't understand how the lab measures the diffusion rate, and you can see on that graph that there were plots for different temperatures. They measured the diffusion rate at different temperatures, and they did by raising and lowering the temperature all the time and getting the amount of helium at different temperatures and calculating the diffusion rate. I mean, I'm sorry, I have to be blunt, but the person who's raising that criticism is ignorant of the actual way in which the diffusion rates were measured in that laboratory. And I might say, again, that those results came from a world-class laboratory by a leading exponent of measuring helium diffusion in his laboratory. I won't mention his name. I won't mention the laboratory. Why? Well, it's in the literature anyway, because that person got very upset when they found out that they did the work for creationists. And we have to do it that way because we know from other work we've tried to do that as soon as they find out you're a creationist, they refuse to do the work for you, even if you pay them to do the work.
Wow.
Yeah.
Doesn't that show the bias in the mindset of those that reject what the Bible clearly says about the age of the earth?
Yeah, well, I had to fight a lawsuit to be able to get samples in the Grand Canyon, and it was documented as worldview bias, which is why I won the lawsuit.
Wow.
That's good.
Praise the Lord. Congratulations on that. That's for sure.